This video is a refresher for how to do your data analysis that will go into your results section. For your methods section, most of you remember that if this were your data, you could get descriptives on anything that was continuous, whether it's your independent variable or not. You need to report both. You need mean, standard deviation, not standard error, and the range, which is determined by minimum and maximum, but not this selection. Don't choose range to report the range. I know that's counterintuitive, but that's the way to do it. So if you wanted the continuous independent variable to report, you click and it tells you that the responses ranged from 1 to 8. The mean was 4.57. The standard deviation was 1.99. To do data analysis, you need to go to the analysis menu and choose the appropriate test. And that's where it gets a little tricky for students. It depends on whether your independent and dependent variable are continuous, that is a range of values. It makes sense. There are the high values and the low values and the middle values. Or you can have category data where there is no rhyme or reason. It's just arbitrary, like 1 equals male, 2 equals female. Let's start with the very easiest analysis. That assumes that you use continuous measures for your independent variable and your dependent variable. If both your independent and dependent variable are measured at the interval or ratio level, then all you have to do is choose bivariate correlations. Use the continuous independent variable and use the continuous dependent variable. Click on Pearson, click on OK, and you're done. Your correlation is the R value, not the T value. And your significance level is the P value. In this particular case, R equals 0.2, P equals 0.49. Not significant because it's not less than 0.05. The next easiest case is if your dependent variable is continuous, but you have a two-category predictor like gender. In that case, you use a t-test. Choose compare means. Assuming the groups are independent of each other, you use the independent samples t-test. Your grouping variable is your categorical independent variable, and your test variable is the dependent variable. Click on OK, and now you have a t-test where you have a difference in means, and at the bottom you have a value for t. Choose the top row if Levine is not significant. Choose the bottom row if Levine is less than 0.05. You report the t value, the df, and the p. That's all there is to a t-test. If, on the other hand, you have a 3 or more category independent variable, then you use an ANOVA. You can go to the Compare Means menu, choose one-way ANOVA, make this 3-category independent variable your grouping variable, and choose your usable continuous dependent variable as the test variable. Clicking on eta squared gives you the power of your test. You can do post hoc tests, but it's not absolutely necessary for COM 301. You get some statistics back after you run the test. You report F. You report the degrees of freedom for the variable and the error term. That would be 2, 11. You report P. And if you want, you can report the effect size, which is 0.22 or 22% explained. The more complicated case is when you have a categorical dependent variable, like let's say, did you vote? 0 is I did not vote, 1 I did vote. There's really no way you could have asked this question so that it was continuous, so you can't beat yourself up over it. But a categorical dependent variable requires a chi-square test. If your independent variable was continuous, a range of values, you're going to have to find the middle and split them into 2 so that you have just 2 categories, or maybe 3 categories to cover the range of values. Chi-square requires that both variables be categories. You can get away with an independent variable as a category by using a t-test or an ANOVA, but once your dependent variable is a category, and in this case, did you vote, did you not vote, you're stuck, then you have to use chi-square, and you have to convert your continuous independent variable into some kind of categorical variable. To run a chi-square, you use analyze chi-squared. Your row is your category dependent variable, and your column or predictor is your category independent variable. The default is observed and expected cell counts. For chi-square, in using Brightstat, you choose Pearson contingency C. Click on OK. The value of chi-squared is 0.285, not very large. The p-value, which is labeled asymptotic p, is much greater than 0.05. This one says 0.59. That's your refresher. That should cover just about any analysis that you want to do. See you next time.